All right, welcome back. So this is another ALEKS topic that's called Deducing the Ions in a Polyatomic Ionic Compound from its Empirical Formula. And basically this is just a topic to introduce the idea of ionic compounds, the charges of our cations and our anions, and then to utilize or work with some polyatomic ions and get more familiar with them. So this is a requested video, so thank you to Karen for the request. And I'm going to go through two different examples of this problem just to give us more, problems to look at, more examples to work through. So let's go ahead and get started. The things that we need to keep in mind when we're looking at these ionic compound formulas is that the overall charge is going to be zero. It's going to be neutrally charged. And so the ratio basically of sodium to chlorine, that's sort of going to tell us the charges on our cations and our anions. So that's what we're going to be looking at. The second thing that we need to keep in mind is that the cation is always going to come first. So the cation is always going to come first in an ionic compound, so that'll tell us this is the positively charged species. And then all we need to figure out is what the charge on that species is. So let's go ahead and do this first one, iron iodide. Now, iron iodide I see as a 1-to-3 ratio between the iron and the I minus. And I know that iodine is going to have a -1 charge. Each iodine is going to have a -1 charge, basically because of where it shows up in the periodic table. It's below chlorine, it's in group 7, and everything in group 7, when it forms an ionic compound, is going to have a -1 charge. So here I'm going to write in iodine with a -1 charge. So I minus, that's what we're going to be looking for our anion. Now our iron, it basically needs to have a charge that will counteract or cancel out or balance out, however you really want to say it, the overall negative charge from all three of those iodines. Since I've got 3 of the iodines, then my charge on the iron needs to be +3. So I'm going to write iron 3+. So now I've got this sort of ratio, 1 iron to 3 iodines. Overall, this ionic compound will have a neutral charge. They'll, all the positive charges will be canceled out by the negative charges, and that's really all we need to do. Let's do the next one, chromium OH. So I again know that OH has a charge of -1. It's a polyatomic ion with a -1 charge. Hydroxide, that's something that as you work with these polyatomic ions, as you get more comfortable with them, then you'll that'll fall into place. If you're having to look those up initially, I think that's totally fine. But as you utilize them and use them, then you will sort of get more comfortable with their relative charges. So now for the chromium, well, just like I said up here, I've got to have that charges balance out. That means that this chromium is going to be 6+. It's going to have a 6+ charge because I've got 6 of these OH minuses, so to balance it out, that chromium needs to have a +6 charge. The next one, NH4, I recognize NH4 again as a polyatomic ion. So you really need to be able to recognize the polyatomic ions, the common polyatomic ions, to do these problems, because you need to know what their charges are and you need to sort of be recognizing those pieces of your ionic compound. So NH4, I know that has a +1 charge, Br minus is a -1 charge. For the Br, you could sort of compare to chlorine and iodine is again in group 7, so it's going to have a -1 charge. That will tell you what the charge on NH4+ is, so you could actually figure that out, right? If you weren't sure what the charge on NH4+ was, you could use the fact that well, Br should be -1. Since it's a 1-to-1 ratio, then that NH4, that whole piece, maybe we'll go like that, that whole piece has a +1 charge. For cobalt, it's going to be cobalt 2+ and oxygen 2-. I know that oxygen is in group 6, so that should be a 2- charge. I almost put the 2 down here because I'm so used to writing O2, but this should be really like O2-, not O2. It's one oxygen. That one oxygen in that ionic compound has a -2 charge. All right, let's do one more set. So this first one, manganese phosphate. So again, I know that phosphate has a charge of 3-, and that's just from being able to recognize it's a polyatomic ion. I know what the charge is. You might not be at that stage, and that's okay for now, right? We're going to work on that. We're going to practice. We're going to get familiar with those polyatomic ions. For our manganese, now I'm going to again look at this ratio between manganese and phosphate. I already know that phosphate has a 3- charge, so that sort of tells me that manganese needs to have a +4 charge or 4+ charge because I need to balance that out, right? So I need to have This is going to have minus 12 total, so I need to have plus 12. So I've got 3 of them. How do I get to plus 12? Well, if each one is plus 4, then that's going to be, how we achieve that. That's one way we could look at the ratio here. Since it's 3 to 4, that indicates that this probably has a plus 4 charge since we've got 4 of these. This probably has a minus 3 charge since we've got 3 of these. Some people sort of draw these like X's here. However you need to figure it out is fine, just so we get to those correct ratios where everything balances out. That's the main take-home message. Here we've got iodine again, so that's going to be I minus, cobalt 2 plus, excuse me, NH4 plus, we saw that before, and then this S should be S2 minus. So sulfur again comes in that group 6, similar to oxygen. In an ionic compound, it's always going to have a charge of minus 2. We already know the NH4 plus has a charge of plus 1. So all this should sort of make sense and sort of fit in. Here we've got chromium with a 4 plus charge, OH minus. And here we see chromium with a varying charge. And those transition metals, it is very common that they would have a varying charge. So we can rest assured that that's okay. Things in group 1, sodium, lithium, potassium, they'll always have a positive 1 charge. Things in group 2, like magnesium, calcium, strontium, those will always have a plus 2 charge. So those plus 1, plus 2, we can always keep those in mind as plus 1 and plus 2, groups 1 and groups 2. Group 7 is always going to be minus 1. Group 6 is always going to be minus 2. And if we just sort of keep those in mind, that's going to get us a pretty far down the road where we need to go. Our polyatomic ions, we need to figure out what the charges on those are. Those are going to vary. And then our transition metals, the things in the middle of the periodic table, those can have varying charges. So we might see plus 4, we might see plus 6 for the same species, just in different forms. All right, hopefully that helps. Let me know if you've got any other questions, and thanks for watching.